Welcome back. So I hope you have been following along with the previous lectures because today we are moving into one of the most practical and industry relevant topics in modern software engineering. In the previous lecture, we covered static code analysis and refactoring and some static analysis tools. However, improving software is only one part of the story. Think about what happens after a developer modifies an existing system. Maybe they add a new feature, perhaps they fix a bug, or they optimize an existing module. Now imagine that dozens or even hundreds of developers are making similar changes every single day. A very important question arises: how can all of these changes be combined safely? How do organizations ensure that one developer's update doesn't accidentally break another developer's work? How do companies release new software updates so frequently while still maintaining software quality and reliability? How can all of these repetitive activities can be automated instead of being performed manually every single time? These are exactly the questions we will answer in today's lecture. So today's session introduces us to one of the most important practices used in modern software engineering and DevOps environments, that is continuous integration using Jenkins. This is what we will be covering. By the end of the lecture 3 series, you will understand not only what continuous integration is, but also why it has become an essential practice for software companies around the world. We will begin by understanding the concept of DevOps and learn why organizations moved away from the traditional approach where the developers, testers, and operations teams work independently. We will see how DevOps encourages collaboration, automation, and continuous feedback throughout the software development lifecycle. After that, we will explore continuous integration, often called CI, and understand how developers can frequently integrate their code changes into a shared repository while ensuring that every change is automatically verified through building, testing, and validation. Once we have established these concepts, we will introduce one of the most widely used automation tools in the industry, that is Jenkins. We will learn what Jenkins is, how its architecture works, and how it automates the repetitive software development tasks such as building applications, executing automated tests, generating reports, and preparing software for deployment. Moving into the practical section of the lecture, we will install Jenkins, explore its dashboard, create our first Jenkins job, configure the source code repository, define build triggers and add build steps, and understand the post-build actions. We will learn how multiple Jenkins jobs can be connected together to create complete automation workflows using build pipelines. As we progress further, we will discuss the difference between continuous delivery and continuous deployment, two concepts that are frequently discussed in DevOps interviews and are widely adopted in industry. One of the most exciting parts of this lecture series is learning about pipeline as a code. Instead of configuring automation through graphical menus, we will learn how modern DevOps teams describe their complete build and deployment process using a Jenkins file. We will study both declarative pipelines and scripted pipelines, understand the difference between them, and learn when each approach should be used. We will also explore advanced pipeline features such as environmental variables, parameters, manual approval steps, post-build actions, and pipelines best practices that are commonly used in enterprise software development. Throughout the lecture, rather than discussing only theoretical concepts, we will continuously relate everything to a real-world example of an online food delivery application. This will help us to understand how all of these DevOps practices work together in an actual software development environment. So by the end of today's session, you will have a complete understanding of how modern software team automates software integration, testing, delivery using Jenkins as part of the continuous integration pipeline. I'll see you in the next session.